Hello, my name is James Frankham and this is my mathematics prop box. This prop box teaches students the ins and outs of creating number sentences with unknown equivalents. It adheres to the Board of Studies Teaching and Educational Standards New South Wales, focusing on the Stage 2 and 3 content strands, numbers and algebra, patterns and algebra, and aims to achieve the substrands ACMNA 083, ACMNA 082, and ACMNA 121. This prop box was developed using Jerome Bruner's concrete, pictorial and abstract learning scaffold, also known as the CPA method. It allows for anyone to become the teacher and work and learn with children. So for instance, if a parent was to take this prop box home, they could use it, hopefully using the information provided, or a teacher could use it with children. The assessment strategies used throughout this prop box are mainly based around the teacher's visual observations. However, there are activity sheets which are filled out by the student which can also be assessed at the end. Students are encouraged to self-assess at the end of every activity using the calculator provided. Activity 1. Balancing Scales. This activity I have adapted from Sorrell, Callingham and Mehr's book, Primary Mathematics, Capitalising on ICT for Today and Tomorrow. This activity uses a set of homemade scales and counters. The homemade scales I have made from a coat hanger with 2 bowls strung on either side. This activity begins Bruner's learning scaffold in that it uses concrete materials to begin students considering number sentences. This activity is a good starter in that it teaches students the importance and gives a physical interpretation of equivalence. So, for instance, in a question 3 plus 4, students would place 3. So they'd use the yellow bowl for their operation. They'd place 3 counters in the bowl. Then, as it's plus 4, they'd add another 4. Then in the orange bowl, they'd use that bowl to work out their answer, which is inevitably 7. And they can use many different strategies, which would then level out the scales. There are a set of questions which which coincide with this activity. They are all related to the operations of mathematics, so addition, subtraction, multiplication, and division. They're always the same design questions. So the first question for each operation is a number story. The second is a straight number sentence, and the third is a number sentence where the answer has already been determined, but one of the numbers is missing for the operation. So if I was to use addition, the first question is, Jonathan has 2 apples. He then picks 2 more. How many apples does Jonathan have altogether? To answer this question, a student would grab 2 apples, as Jonathan has 2 apples, and place them in the operation bowl. Jonathan then picks 2 more, so they'd place 2 more counters. As you can see, the scales are uneven now. So students would come over here to their equals bowl, and would then try to level out the scales by using many strategies. So they'd say he has 2 apples, so they'd place 2 in there, and then they'd say, they might use the count on strategy. So he collects 2 more apples, 1, 2. So that's basically how it goes. 2 plus 2 equals 4. So Jonathan has 4 apples. The second question is very similar to that, except it uses a straight out number sentence. This is good because it begins students visualizing and working with number sentences. The third question, for instance with addition, I have 5 plus something equals 8. Students would begin on this side of the scales where the equals are. So they know that 5 plus something equals 8. So they'd place 8 counters in this bowl. Now they know that it's 5 plus something. So they'd come over to this bowl and place 5 in. 5 counters. Now, you can't really see because of the camera angle, but the scales are fairly uneven still. So again, they'd use another strategy to work it out. So, for instance, the count-on strategy again. So then they'd go 5, so 6, 7, 8. And once again, the scales have leveled out. There is an ICT extension of this activity, which is from the Top Marks website, where basically they use the same idea of the scales. However, there are many more variations of questions, and the questions can be scaffolded from primary to even high school mathematics levels. Also, a variation of this activity, of the physical activity, students can not only make their own set of scales, but they can also place different objects which obviously would have the same weight and mass, and link their mathematical learning with items they can relate to. So a child might put toy soldiers in either side and count how many toy soldiers they have and use that as an equivalence. So that's activity 1. Students have attempted the hands-on experience within the balancing scales activity. Now it is time they begin to see representations of processes within the pictorial stage, which is also the P stage in Bruner's CPA scaffold. I've linked this stage of Bruner's scaffold between 3 different activities. These activities are all use pictures and pictorial representations, so that students begin to visualize the processes and reasoning of number sentences. Activity 2, creating number sentences. This activity teaches students the correct syntax of number sentences. By syntax, I mean this is similar to using the correct grammar and punctuation in English. This activity teaches students the correct order of operations, left to right, and shows how the equal sign can also mean the same as. This activity, with the questions provided up here, also begins to teach students the real-life situations and the correct mathematical procedures of number sentences. I adapted my idea of this from the Victoria State Government Education and Training website. For this activity, students require a calculator and the number sentence templates, which are in the prop box. There's an example sheet up here which explains to students how the correct operations of number sentences, and gives an example. The questions provided on this sheet are similar to the last question sheet in that they follow the same operations: addition, subtraction, multiplication and division, and are up to the teacher's discretion whether what level their students at to use them. For this activity, students would use the number sentence templates to answer the questions which are posed from number stories. So for instance, if I was to use the multiplication operation, and I was given a question, for instance, there are 3 bags of 4 gumballs, how many gumballs are there altogether? So, first I'd work out my operation, which is multiplication. I would then write in the first large box my number. So there are 3 bags of 4 gumballs. So my operation would be 3. I'd write in the small box my operation, so times 4. Now 3 times 4, students would be provided with a, depending on their level of knowledge, they can be provided with a multiplication grid. However, it's better that they try to use their own knowledge without instead of taking the easy way out. So 3 times 4 equals 12. An extension of this activity would be that students are to create the inverse operations. So an inverse operation would be, technically it would just be, it's the opposite of the operation just done. So 3 times 4 equals 12. So students could flip this number template around. So students would go the opposite way. So they would begin with 12 divided by 4 equals 3. That's how students would begin to understand the concept of inverse relationships and how number sentences can be changed and adapted to suit. Activity 3, picture cards and number sentences, is the second activity in Bruner's pictorial stage. This activity focuses on students creating number stories. It is designed to promote students considering patterns in real-life situations. It's also the next step into students creating abstract number sentences, so the actual process that they're finally to achieve. For this activity, students firstly select a picture number card from the deck. Now the deck has already been shuffled, so they select one. So 2 cars. They then choose an operation. So we have addition, subtraction, multiplication, or division. Now for division, students are also encouraged to consider whether or not this the process would work. So for instance, if I had 2 cars and then say I pulled a 3, well 2 cannot be divided by 3. So therefore students would be encouraged to sort of start considering whether or not they've gotten the question right or wrong, or whether it can actually work. So for this sake, and the same goes for subtraction as well. So for the sake of this explanation, I'll use addition. So I've selected 2 cars. Then I select my next card, 6. So to create the number story, I could say, for example, Barry has 2 cars and purchases 6 more for his factory. How many cars does Barry have? Another instance, so I could pull another card. So 10 rabbits. And I pull out my other number card, 2. Activity 4, reading number sentences, is the third and final stage of Bruner's pictorial scaffold. This activity is the crossover between students comprehending pictorial and abstract materials. This activity is pictorial in the sense that they're given the structure of the scaffold in front of them using this number sentence template of a number sentence. However, it's abstract in the sense that they're creating their own number sentences already using these templates. This activity has links to algebra in the fact that students use symbols which represent numbers. Once again, I've used Sorrell, Callingham and Muir's book, and basically this activity is another way of showing equivalence in a visual way to children. For this activity, in this activity, children begin to recognise that there are different ways of expressing numbers, and that different numbers can be used to make equivalent expressions. So basically this activity is a scaffold to algebraic thinking and basically students creating number sentences. So this activity, I have 3 cups. Each cup contains a different set of cards. So this top cup contains number cards, so 1 to 9. The second cup contains images, so a square, a triangle, a circle and a love heart. Now according to this sheet up here, a square is equal to 5, a triangle is equal to number 2, a circle is equal to the number 6, and a love heart is equal to the number 3. Now in this final cup down here, that is where students pick their operation. So basically this activity is quite creative, so students need to create their own number sentences, as well as also use their mathematical knowledge and actually work out the question. So to begin this activity, students pick one number card, or they can also pick a shape card. It depends on them. So I'm going to pick a number card. So, sorry, I've selected the wrong one. So I've selected number 2. Then I select my operation card. So I come down here and I select my operation. So I've found an addition card. And secondly, I look for my shape card. So I've pulled a square. Now, as we know from up here, a square is equal to 5. So I come over here to my template and I create my my number sentence. So 2 plus square equals, well, I know that the square is equal to 5, so a student can use whatever mental strategy they wish. So 5, I can use the count on strategy. 6, 7. So 2 plus 5 equals 7. So that's how I do the first half of this activity. And I'd use it, so every operation is in that. So there's division, multiplication, and subtraction. There are 10 rabbits fit into a den. There are 2 dens. How many rabbits are there altogether? So simple questions like that sort of promote students comprehending and considering all the different real life situations that there are out there, and promotes them actually writing these stories out on this sheet here provided. Activity 4, reading number sentences, is the third and final stage of Bruner's pictorial scaffold. This activity is the crossover between students comprehending pictorial and abstract materials. This activity is pictorial in the sense that they're given the structure of the scaffold in front of them using this number sentence template of a number sentence. However, it's abstract in the sense that they're creating their own number sentences already using these templates. This activity has links to algebra in the fact that students use symbols which represent numbers. Once again, I've used Sorrell, Callingham and Muir's book, and basically this activity is another way of showing equivalence in a visual way to children. Children begin to recognise that there are different ways of expressing numbers, and that different numbers can be used to make equivalent expressions. So basically this activity is a scaffold to algebraic thinking and and basically students creating number sentences. So this activity, I have 3 cups. Each cup contains a different set of cards. So this top cup contains number cards, so 1 to 9. The second cup contains images, so a square, a triangle, a circle and a love heart. Now so according to this sheet up here, a square is equal to 5, a triangle is equal to number 2, a circle is equal to the number 6, and a love heart is equal to the number 3. Now in this final cup down here, that is where students pick their operation. So basically this activity is quite creative, so students need to create their own number sentences, as well as also use their mathematical knowledge and actually work out the question. So to begin this activity, students pick one number card, or they can also pick a shape card. It depends on them. So I'm going to pick a number card. So, sorry, I've selected the wrong one. So I've selected number 2. Then I select my operation card. So I come down here and I select my operation. So I've found an addition card. And secondly, I look for my shape card. So I've pulled a square. Now, as we know from up here, a square is equal to 5. So I come over here to my template and I create my my number sentence. So 2 plus square equals, well, I know that the square is equal to 5, so a student can use whatever mental strategy they wish. So 5, I can use the count on strategy. 6, 7. So 2 plus 5 equals 7. So that's how I do the first half of this activity. The second part of this activity, students, so once I've answered the first 4 templates and I've filled them out, the second half of this activity requires students to create an inverse operation. So, I'll go with a picture card this time. So I've pulled a love heart, and I'll go with my operation card. So I've found a multiplication. Then I'll go with my other one, with my number. I found an 8. So this equals, so we know a love heart equals 3. So I draw my love heart. So 3 times 8, which I know is 24. Now students would create the inverse operation. So they'd use they've already been informed in the previous activities that the opposite, so multiplication is division. So the inverse operation would be 24 divided by 8 equals 3. Then students would follow that through for the second question as well. There is a ICT extension of this activity which can be found on the AAA math website. Basically it's just got a heap of activities and question generators, and also gives students a mark at the end. So it also generates numbers, and also students can place in their own numbers to allow them to I guess create their own number senses and scaffold their own learning. The fifth and final activity in my prop box is a game called Creating a Number Sentence. This game basically is part of the abstract and final level of Bruner's scaffold. It's abstract in the sense that there is no pictorial material for students to use. They have to use their knowledge of creating number sentences to win this game. Now the way students play this game, so you'd have students pitted against each other, or the teacher can play against the student as well, perhaps probably bringing their level down so the student can actually have a chance. What you'll need, so they also require a timer, so students could use an iPhone or their iPad to use an app which basically allows them to do track records. So they could say basically for the first half they could stop it at 10 seconds, and the second one they'd stop it at a certain time. And basically it challenges students to get faster and faster at computing their mathematical skills, and also places a bit of pressure on them to actually write out a correct number sentence. This activity can be used as an assessment overall of how students can fill out number sentences, in that the teacher can actually assess what kinds of number sentences the students are making and how they work, and if they work, sorry. So to begin the game, students grab the first card. So I've grabbed number 6. Then down the side of each board they have the rule which they must follow. Now they have to follow each level consecutively. So for the first one, both players have got a plus, or addition, sorry. I've pulled a 6. So now they start the timer, and the second student pulls out the next card, which is a 4. So using addition, the rule, like the addition rule, they've got the numbers 6 plus 4, and the equation which they have to write out, which both these players in this example have used 6 plus 4, which equals 10. Now whoever gets the equation and answers it first is the first one to stop the timer. Students can write down their time, but it's not really generally necessary as long as they've written it all out first. So we move down to our next level on the board. So player 1 has an addition and player 2 has a subtraction. So the student would pull out the next card, which is 2. So that's their first number. So 2. Now all these rules are all evened up, so there's 2 of each rule, so each student has an equal chance. Then students would start the timer and pull their next number. So 5. So player 1, using their knowledge of addition, would write a simple equation such as 2 plus 5, which equals 7. Then player 2, their rule is minus, so they'd have to create an equation. So in their head, obviously 2 minus 5 wouldn't work, so they'd go with 5 minus 2 equals 3, and so on. Now this game continues on, so the next level, player 1 would have a subtraction, player 2 would have an addition, multiplication, sorry, and carries on like that. This sheet can also, the teacher can use this sheet and assess their knowledge afterwards as well to see how they've adapted and use their knowledge of number sentences.